All right, this is Ms. Katz again, and today we are going to learn how to use ratio tables to find equivalent ratios, okay? So we've been doing simplifying for a really long time, right? We've been simplifying fractions forever, and those, when we simplify a fraction, we're getting two equivalent fractions. Same thing goes for ratios. If we simplify them, or if we blow them up, whatever we do, as long as we're doing the same thing to the top that we do to the bottom, we're going to have equivalent ratios. So a ratio table, you guys should be filling this in, please, is a table of values that displays those equivalent ratios. It's just a way to organize them. Jordan. Then you need to copy these down right now. All right. I'm going to just show you a couple of examples, and then I'm really going to dig into how we actually use them to find equivalent ratios. So if you look at this table, this first table here says that for every one soda, this is ratio language I'm using, for every one soda, there were 3 juices that were purchased, okay? For every one soda, 3 juices. Which means if I bought 2 sodas, how many juices will I have? 6. And if I bought 3 sodas, I would be buying 9. Now, let me show you how a ratio table helps us organize that information. Using multiplication or division, how did I get from 1 to 2? Sophie. Using multiplication or division, how did I get from 1 to 2?
Okay, you use multiplication because 3 times 3 equals 6. So.
How did I get from 1 to 2, sweetie? Using multiplication or division. You had your hand up. You got a thought in there about this particular? There you go. That's what I was looking for. We're going to multiply times 2. Whatever I do to the top of a ratio, I have to do to the bottom. So if you notice, when I multiply by 2 down here, I'm going to get that's where that 6 comes from. And we can create an infinite number of equivalent ratios by just multiplying any of them by some number. Okay? Now we're going to actually flip over. I'm going to skip some of these examples a little bit and go right into the work. Yes, sir.
I remember you talking about how multiples never end.
Yep.
Is ratios just like that?
Well, when we make additional ratios that are equivalent, they never end because we're multiplying to make them, right? That's a great connection. I love that. All right, let's take a look at number 1. So the known relationship that we have is we've got 2 in relation to 4. 2 to 4 is the ratio we know. We're going to use that information to find the missing pieces. So since I know the 8, I want to get from 2 to this empty box. Does everybody agree? I'm trying to figure out what that empty box is. Hold on. I know that if I want to do that, I've got to do the same thing down here. So tell me what the relationship is between 4 and 8. Deanna. What 2? Times 2. I multiplied by 2 to get that 8. Whatever I do on the bottom, I have to do on the top. So when I multiply on the top, what am I going to get? 4. There we go. Okay? It is easy. None of this is hard. I want you to understand this unit is awesome. It is. And we've been doing this all year. We've just been doing it in different formats. So this isn't really new. It's just a new way to look at it. Okay? So now let me ask you a question. I know the 6, right? So I'm going to use from 2 to 6. How did I get from 2 to 6? So I have to do the same thing on the bottom. So what will this number be? 12. Okay. Notice, by the way, I'm not skip counting. I'm not going from one to the next. I'm using the relationship I know to build the relationships I'm seeking. Okay? So don't assume they're going to go in order or they're going to skip count. Like this one does happen to like plus 2. I mean, actually, this one doesn't skip count because we're missing 1 somewhere in there. Or maybe not. We're missing the 8, yeah. But we know 2 to 10. What did I do to get there? Times 5. Whatever I do on top, and when I multiply times 5, what do I get? 20. Okay? So that's the simplest kind of ratio table we can deal with, where the relationships match up really easily, and you can relate them, okay? Hold on one second. Hold that thought. Let me show you one, though, where you might not see that relationship so easily. Okay? And then, well, actually, Johanna first, because she had her hand up first.
So, like if it had to be, there can be, different?
They could be. They may skip count, but don't count on that. We should always go to the relationship we have established. In this case, it was 2 to 4, and use that to get the rest of them. Okay? Brooke, what was your question?
I'm still confused on how to
Okay, how did we get 20? Well, we knew that to get from 2 to 10, I had to multiply by what? 5. Whatever I did on top, I have to do on the
Bottom.
and so 4 times 5 got me the 20. Does that make sense? Okay, let me show you one. Number 5, I want to skip down to. We're going to do more of these in a minute. But for number 5, shh, listen. I don't have a real relationship that I can count on so easily, necessarily. I don't know how to get from 27 to 21 so easily, right? But can I simplify this fraction? All right, if I simplify it, what number goes into both 27 and 36? 3 would, but there's a bigger number. 9. What's 27 divided by 9? 3. And what's 36 divided by 9? All right, now that I've got that little guy, that guy can help me get everything else because we can relate that. So if I want to go from 3 to 21, how did I do that? Times 7. Whatever I do on top, I have to do on the. So from 4 to this, it's times 7. What will this be? 28. Let's take a look. How did I get from 3 to 9? How did I get from 3 to 9? What about 3? Times 3. Remember, we could multiply or divide, so you guys got to be specific. So whatever I do on the top, I have to do on the bottom. So here we're going to multiply by 3, and what do I get? 12. We've already established that the ratio here is what? 3 to... So what do you think this is going to be? Yeah, 3 to 4. Okay. All of these, do me a favor. Simplify 9/12 and 21/28. Tell me what you get. Quick, on your paper. Simplify 9/12 and 21/28. You got it? What'd you get? Yeah, 3 over what? Not 3 over 3. 3 over 4. Doesn't that make sense? Right. These are all equivalent fractions. What's the most simplified fraction we have? 3 over 4. They will all simplify to 3 over 4. They're just dressing them up in different clothes. Okay? Now let's take a look. Yes, ma'am.
It's kind of like, sort of like all the things in 3, most things in 4.
Yeah.
Like, there's 2 things in 4.
Yeah, and actually, Brooke, you're absolutely right. We could go out, take all of our 3s, like our multiples of 3, and all of our multiples of 4, and we would keep getting equivalent ratios over and over and over again. Johanna, you don't get it? Well, let's do another one. Let's take a look at question number 15. Okay, 15. So again, I can't relate right now. I don't know how to relate 32 and 24 so easily. We don't have that simple, right? So can I simplify this fraction to make it easier to work with? All right, so Alex, since you are so sure, what factor goes into 32 and 36? 2 does. Okay, so what do you get when you divide by 2? You could. What could you go to? 4? You could even go higher. 8. So how many 8s go into 32? 4. How many? Oh, no, not 4. 8 doesn't go into... It is 4, sorry. But 8 doesn't go into 36, so we can't use that. Hold on. 8 doesn't go into 36. We can't use that one. What goes into 32 and...
12.
4? We liked 4, right? Let's do 4. When I divide by 4 on top, what do I get? What's 32 divided by 4, guys?
8.
And what's 36 divided by 4? Yes? She'll be right up.
Okay, ma'am, thank you.
Shh. All right. We were... Let's not get distracted by that. To the main office, honey. Do you know where that is? If you go out the cafeteria doors, it's right across the hall. Shh. So, 8/9 is my simplified fraction. Now I can use that. So, how do I get from 8 to 24, guys?
3.
Times 3. Whatever I do on top, I do on the... So, times 3, what do I get?
27.
Okay. How do I get from 8 to 16? Whatever I do on top?
18.
Oh, why are you? We got to work on that.
Are you multiplying like the number that's the closest?
What you're doing, Deanna, is I know, excuse me, ladies and gentlemen, I know that this 24 exists, right? So I want to figure out, what did I have to do to get from 8 to 24? 3. Whatever I did on the top, I'm going to apply that same relationship on the bottom to get a match.
So you're just trying to find the closest number to
Yes, you're trying to, yes.
Okay.
And what you need is, you need a relationship that you can establish that can help you. Do you want to do the next one? Is that what you're saying? 4? Sure. All right, let's do number 4. If you guys get this, by the way, first of all, you should, because it's really not hard. But for some reason, one of my classes in particular, I won't even call them out, but was really struggling. So let's make this not be you. All right. So for number, remember that this is recording. You don't want me calling you out on record. Look at number 4, Johanna. I've got a relationship I know. It's already simplified, right? I want to know, how could I get from 2 to 6? Times 3. Whatever I do on the top, I've got to do to the bottom. So what do I get?
15.
15. All right, let's do this one more time. How did I get from 2 to 8? Times 4. Whatever I do on the top, I do on the... So what's 5 times 4? And then I want you guys to do me a favor. Try to finish these 16 problems. We've done a bunch of them.
I get it. What?
I'll come around if you need help. Look at them. I forgot to hit. Stop.